Welcome into today's deep dive. If you're tracking the current state of software defense, you probably already know we're dealing with a pretty severe asymmetry problem right now.
Yeah, that's putting it mildly.
Right. Because artificial intelligence is drastically lowering the barrier to entry for malicious actors. It's allowing them to scan for and exploit vulnerabilities at a scale we simply haven't seen before.
Exactly. The scale is just unprecedented.
So today, our mission is looking at how the defense is attempting to level that playing field. We are pulling from a really great article in Cybersecurity News by Guru Baran.
Hmm.
It was published on March 6th, 2026, and it's titled OpenAnt AI-based vulnerability scanner to detect vulnerabilities. Okay, let's unpack this because we are seeing an explosion of AI-discovered vulnerabilities, particularly targeting open source software.
Yeah, open source is getting hammered.
It is. And the traditional methods of just, patching and praying, they're no longer viable at all.
No, they're really not. The asymmetry you mentioned, that's the defining characteristic of the current threat landscape. And for you, the listener, understanding the architecture of a tool like OpenAnt provides a remarkably clear window into the cutting-edge arms race of modern cybersecurity.
It really does.
Because, we are constantly inundated with reports of large language models being weaponized to just comb through repositories and find 0 days. Observing how those exact same underlying models are being reverse engineered into defensive, automated testing suites, it gives you a highly accurate picture of where enterprise security and open source maintenance are heading over the next few years.
Which brings us directly to the countermeasure we are analyzing today. OpenAnt is an open source, LLM-based vulnerability discovery tool,
Right.
and it is currently sitting on GitHub under the Apache 2.0 license. What stands out immediately in the source material is its development trajectory. I mean, it didn't just spawn as a corporate product.
No, no, no.
The article outlines that OpenAnt actually began as a focused research project by Nahum Korda.
Yeah, a solo research initiative.
Exactly. And from there, the productization, actually turning it into a stable, usable command line tool, was driven by Alex Rehelgaus and Daniel Gaishes from a company called Gnostic.
And that transition is huge. Moving from a research sandbox to a production-ready utility is notoriously difficult when you're dealing with large language models.
Because it just has to be reliable, right?
Exactly. A research script only has to work once to prove a concept. A deployed vulnerability scanner has to work consistently across wildly different code bases. It has to deal with edge cases, strange dependencies, and varied syntax without crashing or hallucinating.
Right.
So Gnostic stepping in to handle that productization phase indicates a really serious push to make this highly practical. And we have to look closely who they are actually building this for.
A target audience.
Yes, the target audience here is specifically security teams and open source maintainers.
Which puts us in a really interesting spot regarding resource allocation. Open source maintainers are the ones maintaining the foundational code the entire internet relies on. But they usually don't have the budget for massive enterprise-grade security suites.
If we connect this to the bigger picture, the open source ecosystem has been operating under immense pressure lately. We've seen numerous high-profile supply chain attacks where a single compromised open source library cascades into thousands of enterprise environments.
It's terrifying, honestly.
It is. And maintainers are often solo developers or just small volunteer teams. They cannot afford the licensing fees for proprietary, commercial, static application security testing or SaaS tools.
Right.
But even if they could afford them, they don't have the bandwidth to deal with the operational overhead those traditional tools create.
Yeah, and that operational overhead usually comes down to noise, right?
Well, absolutely.
The traditional flaw with static analysis is the sheer volume of false positives. Gnostic actually addressed this directly in the article. Let me read this quote from them. They stated, "Considering the explosion of AI-discovered vulnerabilities, we hope OpenAnt will be the tool helping open source maintainers stay ahead of attackers."
They are specifically attempting to arm the grassroots defenders.
Yeah, because when a traditional SaaS tool relies purely on pattern matching or abstract syntax tree queries, it flags everything that even remotely resembles a bad practice.
It's overwhelming.
Developers end up drowning in alerts, leading to total alert fatigue, where they simply start ignoring the dashboard because triaging the output takes longer than writing the feature itself.
Exactly. You end up with security dashboards showing thousands of critical vulnerabilities that are actually just unreachable code paths or totally safe internal functions.
Right, the boy who cried wolf syndrome.
Precisely. OpenAnt tackles this by restructuring the scanning architecture into a very specific two-stage pipeline.
This is the cool part.
Yeah, stage one is the detection phase, which operates somewhat similarly to traditional analysis. It scans the code base to identify potential areas of weakness. But stage two is where the methodology completely shifts.
It flips the script.
It does. It transitions from static analysis to dynamic verification. It actively attempts to attack the vulnerabilities it just found.
It's basically like hiring a security guard who doesn't just check to see if your front door is locked in stage one,
Right.
but they actually try to pick the lock and break into your house to prove it's not secure for stage two.
That's a perfect analogy. It is essentially an automated red team operating directly on your commits.
Yeah.
Instead of just highlighting a slightly outdated cryptography library or a potentially unsanitized input, OpenAnt acts like an autonomous penetration tester. It looks at the potential flaw, generates the necessary exploit payload, and simulates the attack in a local sandbox environment.
And if the exploit fails.
If the exploit fails, the tool drops the alert. It only surfaces the finding to the maintainer if it successfully breaches the code.
That is massive for signal accuracy. Only the verified results make it through.
The implications of that two-stage verification process are just game-changing for developer velocity. By forcing the system to mathematically prove the exploitability of a flaw, OpenAnt aggressively filters out the noise.
It shifts the burden of proof.
Exactly. It shifts the burden of proof from the human developer back onto the machine. When an alert actually makes it through that second stage and lands on a maintainer's desk, it comes with the verified exploit path.
So they aren't chasing ghosts?
No, they are looking at a confirmed actionable breach that requires immediate patching.
To achieve that level of autonomous exploitation, though, you need serious reasoning capabilities. You can't just use a basic model.
You really can't.
The article details that the engine driving both the analysis and the verification stages is Anthropic's Claude Opus 4.6, accessed via API.
It's a heavy hitter.
It is. And this relies on a bring-your-own-key model. Users actually have to supply their own Anthropic API key with access to that specific Opus 4.6 model to run the pipeline.
Relying specifically on Opus 4.6 is a calculated architectural decision by the team. When you're asking an AI to analyze code, find a flaw, write a custom exploit, and then execute it, you are demanding a very high degree of logical reasoning and context retention.
Lighter models just wouldn't cut it.
No, lighter models simply hallucinate the exploit syntax, or they lose the thread of the data flow halfway through.
But there's a trade-off there with the bring-your-own-key approach.
For sure, it shifts the compute cost of that heavy model directly to the user. It allows Gnostic to offer the tool itself for free, but the maintainer absorbs the token costs of the analysis.
Let's break down how that analysis actually executes under the hood, because the technical workflow Gnostic designed for this is highly structured.
It's very clean.
Yeah. OpenAnt operates through a command line interface utilizing a 6-step sequential pipeline.
Right.
The commands are parse, enhance, analyze, verify, build output, and report.
Unpacking that sequence reveals how they are managing the interaction with the LLM to optimize those token costs we just talked about.
Right. They don't want to just feed it everything at once.
Exactly. The parse step likely involves breaking down the target repository into manageable semantic chunks, stripping out irrelevant binaries or static assets to ensure the LLM isn't wasting context window on useless data.
That makes sense.
Then the enhance phase would be where the tool maps out the dependency trees and data flow, giving the AI the broader context of how a specific function interacts with the rest of the application.
Which perfectly sets up the analyze phase. That's where the first API calls to Claude Opus 4.6 are likely made to identify the potential flaws based on that enhanced context. Then it pushes into the verify command, triggering that attack simulation we discussed.
The fun part.
Yeah, the break-in. Once that simulation concludes, the build output command structures the verified findings into a machine-readable format, likely something like JSON or Serif, so it can be ingested by other CI/CD tools.
Before finally running the report command to generate the human-readable summary.
Right. It's a very deliberate separation of concerns.
It is. However, running a 6-step CLI process manually for every single pull request introduces a lot of friction. For a security tool to gain actual traction among developers today, it has to be basically frictionless to deploy.
Gnostic clearly recognized that because they included a unified shortcut for the impatient learner.
Thank goodness.
Yeah. Instead of stepping through all 6 commands, a developer can execute the entire 2-stage pipeline by just running OpenAnt scan verify.
Simple as that.
That single command triggers the parsing, the enhancement, the LLM analysis, the attack simulation, and the final reporting in one continuous automated flow.
which makes it trivial to drop into a GitHub action or a GitLab CI pipeline. Now, regarding applicability, the underlying syntax of the code base dictates how effectively an LLM can parse and exploit it.
Right, it doesn't just magically understand everything equally.
No. The compatibility chart provided in the documentation categorizes Go and Python as highly stable and fully supported right now.
And the beta tier includes JavaScript and TypeScript, C and C++, Symmetry, PHP, and Ruby.
It makes sense that Go and Python are the stable frontrunners here, given that so much of modern backend infrastructure and AI tooling is written in those languages.
Absolutely.
Go and Python also offer somewhat more predictable execution environments for automated testing compared to the memory management complexities of C++ or the dynamic typing quirks of JavaScript.
Yeah, C++ can be a nightmare to simulate.
Oh, an AI trying to write an exploit for C++ has to account for highly specific memory allocation states, which is incredibly difficult to simulate reliably in an automated sandbox.
Yeah.
Gnostic placing those languages in beta indicates they are still fine-tuning the deterministic accuracy of the exploit generation for those specific syntax structures.
Now, for developers looking to integrate this, there are a few strict technical prerequisites. Because the CLI binary is built with Go, your environment needs to be running Go version 1.25 or higher to compile it.
Good to know.
On the repository side, the tool is flexible. It handles remote repository cloning via URL, but it also heavily supports local directory referencing.
Which is great for local testing.
Definitely. And a key feature highlighted in the article is its support for commit pinning. This allows you to lock the scan to a specific point in time so your security audits are perfectly reproducible later.
That reproducibility is essential for compliance and auditing. But what demands the most attention when deploying any third-party AI tool that requires high-level API access is the security architecture of the tool itself.
This is critical.
Because you are feeding this program your proprietary source code and a billing-enabled API key. If the scanner's telemetry is routing that data to an external server somewhere, you've just created a massive data exfiltration risk.
Right. But Gnostic handles that by keeping the architecture strictly localized. All configuration files and project data remain stored locally on the user's machine.
Inside the .config OpenAnt and .openAnt directories.
Exactly. There is no cloud dashboard or centralized SaaS platform vacuuming up your repository data. And to protect the user's Anthropic credentials, the API keys are locked behind strict 0600 local file permissions.
Locking those keys under EO600 permissions is a non-negotiable standard, especially considering how these tools are usually deployed. If a development team is running OpenAnt on a shared CI/CD runner, those strict user-level read-write constraints ensure that no other process or lateral movement within that environment can access the Opus key.
Because that could get expensive fast.
Given the heavy token consumption required for generating exploit code, a compromised key could result in severe financial impact in a matter of hours.
Here's where it gets really interesting. We have to look at the timing of this release.
Oh, the market timing is fascinating.
March 2026 is seeing an aggressive surge in the AI security market. OpenAnt is launching into a highly contested space. The article notes the rapid proliferation of competing AI-powered vulnerability tools from the major foundational model providers themselves.
The big players are moving in.
Yeah, OpenAI is pushing their Codex security suite, which evolved from their Aardvark project. And Anthropic is actively operating in the same lane with Claude Code Security.
What's fascinating here is Gnostic's strategic positioning within that landscape. When the companies building the foundational LLMs enter the security tooling market, they generally focus on massive enterprise contracts.
They want the big fish.
They do. They build heavy, compliance-focused SaaS platforms. Gnostic has made it explicitly clear they are not trying to compete for those enterprise contracts.
Right.
They are not positioning OpenAnt as an alternative to Codex security for Fortune 500 companies.
Their entire market approach is focused on transparency and community defense. By open sourcing the tool and focusing on the maintainers who are priced out of the enterprise tools, they are attempting to secure the foundation of the supply chain rather than the top of it.
That's a great way to put it.
And this isn't just a theoretical white paper project. The article points out as a proof of concept that Gnostic is already utilizing OpenAnt in the wild.
Yeah, they're using it right now.
They are actively engaged in the vulnerability disclosure process for flaws they actually discovered in external projects during OpenAnt's own development cycle.
The fact that they are already navigating coordinated disclosure proves the efficacy of the two-stage pipeline. The tool successfully parsed real-world repositories, identified previously unknown vulnerabilities that static analysis had missed, generated the exploits, verified the breach, and generated actionable reports.
So they're essentially dogfooding their own scanner to validate the architecture.
Yes, and they're producing actionable results.
And they're using that validation to drive adoption and crowdsource the ongoing development. The article highlights an active call to action for the broader community. Because major languages like C++ and JavaScript are still in beta, Gnostic is welcoming community contributions.
They need the help to scale it.
Right. They're inviting independent security researchers to validate, extend, and improve the tool's capabilities. They are even providing token cost estimates directly on the GitHub repository so developers can accurately project their Anthropic API overhead before committing to a scan.
Providing those token estimates upfront is a critical piece of operational transparency. Unpredictable LLM costs are a primary reason many development teams hesitate to integrate AI-driven analysis into continuous integration pipelines.
Nobody wants a surprise bill.
Exactly. By detailing the expected token burn rate, Gnostic allows engineering managers to calculate the exact ROI of running OpenAnt versus paying a security consultant to manually audit the code.
So what does this all mean for you, the listener? When we pull all these threads together, the overwhelming speed of AI-generated threats, the severe resource constraints on the developers maintaining our critical infrastructure, and the deployment of a localized two-stage verification tool, it fundamentally points to the democratization of advanced security testing.
It levels the playing field.
It really does. By placing an autonomous red-teaming AI directly into the hands of open-source maintainers, Gnostic is providing the tools necessary to defend the underlying code that powers the apps, websites, and infrastructure you interact with every single day. The technology is advancing rapidly, and ensuring the defense has access to the same caliber of automation as the offense is the only way to stabilize the ecosystem. Thank you for joining us on this deep dive. Stay curious, stay informed.
OpenAnt relies on Claude Opus 4.6 to simulate attacks and verify vulnerabilities. It's incredibly powerful. But if an off-the-shelf LLM is now smart enough to successfully exploit code to protect it, what does it mean for the future of software when malicious actors inevitably use those exact same LLMs to attack systems that don't have an OpenAnt defending them?